Just started the recording, so all noises are for real. Let me welcome you all to the Community Council Sunday presentation of Searching for Life on Mars. We have with us today from Cornell's SPIFy place, the Spacecraft Planetary Imaging Facility, Zoe Ponterio, who's going to be talking and presenting all of the information. Before she starts, let me just tell you that Community Council is funded by the town of Danby, and since we call this a family program, some of that funding comes from the United Way. And we have no more actual on-screen programs this month, but starting next Saturday, from the 13th until the following Sunday on the 21st, we're hoping that everyone will decorate your driveway. Find something really ridiculous that people will enjoy seeing, put it at the end of your driveway, wait till the week starts, and then take yourself a tour around town. I have no idea what's going to be out there. I know that, well, our pink flamingo is already in the driveway, so we can't put that out there. We'll find something ridiculous. Perhaps, maybe we could find a very big chicken, but it would get wet. We'll find something. So I hope you'll all participate with that. And we still haven't pinned down a date for the maple sugaring program. If you haven't yet thought about doing that and you want to join at the very last minute, send an email to programs, as in programs, at danbycc.org. And that's on your screen right now. And just let us know. Right now, we're tentatively thinking about Wednesday this week, 2 p.m., and possibly a second repeat on the weekend. And the dates are really, they've been shifting rapidly as the weather changes. We need to have a night when it's kind of cold overnight, below freezing, and nice and warm during the day, so the sap is running. And I think I've gotten all of the announcements out of the way. So let me introduce to you Zoe, who's has a very dry presentation, dry and cold, she said. But that's referring to the subject, Mars. Zoe, you're on.
All right. Well, thank you very much for that introduction, Ted. I like this idea of something big in your lawn. We live up in Lansing, so kind of on the other side of Ithaca from you, but when we bought this house, it's kind of hard to pick it out from the road, and my husband had the idea, what if we put something like really distinctive in our yard so that it was obvious? We always say the house with this, and I found an enormous scrap metal dragon sculpture that someone did, and that got vetoed, unfortunately. So but I love that idea. That would be so fun to drive around and see all what people put in their yards. So yes, you might notice behind me is something that looks very much like a desert, and many of you might recognize that this is in fact not Earth. This is an image from the surface of Mars, and this is indeed one of the latest images down of the surface of Mars from our new site that we're exploring that we have just landed at. So hopefully you've been hearing something about the fact that back on February 18th, so just 3 weeks ago, we landed a new spacecraft on the surface of Mars, the Mars 2020 mission, which has two parts to it. The one you probably heard the most about is the rover named Perseverance, or we call her Percy for short. But there's a second spacecraft. Mars 2020 is not just a rover, it also is a helicopter named Ingenuity. And so to show you a bit of what we're thinking, here is a picture of the rover kind of in the distance, and what will hopefully be happening in the next week or so sometime, they haven't put out an exact date, will be the first test flight of the Ingenuity helicopter. And this is going to be our Wright brothers moment in planetary exploration, because we have never done powered flight on the surface of another world. And so this will hopefully be the first time we demonstrate that this technology can work. It doesn't really have much on it other than a camera to take some cool aerial footage. So it's really kind of just a drone. But That's because we don't know whether or not it's going to work. We have tested it in all the conditions we can simulate here on Earth, but ultimately we know that the only way to know if something's going to work on Mars is to try it on Mars. So I have a lot of confidence that's going to work because I've seen the tests, but understand that this is an especially challenging thing to do because of Mars's atmosphere. So you might know that it is both cold and dry, and both of those things are largely due to the fact it's very thin. The air is 100 times thinner on Mars than it is here on Earth. There is less gravity, right? It's almost down by a factor of 3, but yeah, it's not easy to fly on Mars with such thin air. So this thing is very light, rather small, and with big blades. You can see 2 layers of blades there. So stay tuned. That's hopefully coming up in the next week or 2. In the meantime, the rover, which is the real meat of the mission and has all the science going on, is literally a rolling laboratory. And as the title implies, one of the key goals of this mission is the search for life on Mars, whether that be ancient life or even current life. Now, I'd love to come on here and tell you, after only 3 weeks, that we've already done our science and looked at the rocks and we have found it. There is life on Mars, mission accomplished. But I bet you all know that that's, of course, not what I'm going to tell you today. This is going to be a long haul in the same way that I'm going to briefly review where we are to this point of answering the question, was there ever a lot of water on Mars? Was Mars ever warmer and wetter and more Earth-like? That did not come overnight in a big press conference. That was a discovery that took a decade or 2 of slowly building up evidence, slowly building and convincing more and more scientists, scientists becoming more convinced personally, until the evidence just became so overwhelming that we all went, yeah, okay, we're going to accept this as supported fact at this point, because we just can't think of any other explanation for everything that we've seen. We fall back on Occam's razor. The simplest explanation tends to be the right one. So with all the things we've discovered, that's where we're at. The simplest explanation is that Mars did once have oceans and rivers and lakes and rain, and was very much more like Earth than it is now. The search for life is going to be very much the same way. It's going to be slow. We're not going to suddenly wake up one morning to this announcement. Pieces of evidence are going to be collected. Some of them are going to be, wow, that's interesting. Ooh, tantalizing. All that could suggest, well, one of the explanations for that could be life. And this is going to happen probably over years. And ultimately, the goal of this rover is not just to do science on Mars, but to do something we've never done before, which is to get samples from Mars back here to Earth. And the reason that's so profound is that when you send a spacecraft, you have to pick a finite number of instruments to put on there, and you are limited by what you can afford, what you can fit, both size and mass wise, what can be operated autonomously with no human needing to be there, what can be operated in the extreme conditions of space or whatever world you're landing on. So that's a lot of limitations. And then the real kicker is that at some point you have to say, these are the instruments we're using. Now, you're still years from launch at that point, and then you launch and you have to get there. And so literally by the time you actually start using your instruments and doing science with them, those instruments are typically 5 to 10 years outdated. And that is just the nature of trying to do in situ planetary exploration, doing your science there with something that never comes back. But the moment you bring something back to Earth, then you're unlimited. You can send it to every lab on Earth. You can carefully dole out and curate the samples for years. New instrument gets invented, just go get a little bit of, fresh sample and hit it with that. We are doing amazing science with the Apollo moon rocks over 50 years later, and the best science ever done with them is being done today by people that weren't even born when they were brought back. So sample return is the ultimate, and many people ask the question, will this rover discover life? I won't say that it's impossible that we would collect enough convincing evidence in situ on Mars with the rover to start to say, yeah, it's pretty obvious that this was life. Not impossible, but much more likely is that scientists are not going to feel comfortable saying that with confidence until they've had a chance to actually see these samples back in their labs with their instruments, and using instruments we can't send to Mars, and controlling for other factors. So that is what I think we need to be prepared for. And as far as when those samples are coming back, that is still not dated. We are still developing the mission that will go and do that. So, but we're not going to wait for that, right? We can go and collect the samples and they can sit there and wait for us. So let's talk a little bit about how did we get here, where we're at and how we got here. The very first decent images of the surface of Mars were disappointing in one respect because there were a lot of craters. It looked very much like the moon at first glance, and that was pretty disappointing to people. They had expected something that would be cold but still more Earth-like. But among the craters were also things that were not craters, things that looked like rivers and canyons that seemed to indicate that there was something more than just old cratered surface here. So these were Viking orbiter images. And then we started to put together color images. We discovered very early on that there is indeed water on Mars. It's just frozen. So Mars does have polar ice caps that have a 1 to 2 mile thick permanent sheet of water ice. And we also saw evidence that Mars was not always this very geologically inactive cratered surface. We saw huge volcanoes that looked long extinct, but clearly this was once a geologically active world. So along with these Viking orbiters was sent 2 Viking landers. And here we see Carl Sagan standing next to a model of one of these landers. Now, this was a pretty ambitious mission because the main thing that the Viking landers were supposed to do was to answer the question, does Mars have life? We jumped straight to that. Does Mars have life? And the problem is that we jumped too fast. People recognize that now. So these Viking landers landed on Mars, got our first images of the surface of Mars to discover that pretty much, yeah, it's red, it's rocky, it's dusty, it's cold, and it's dry. Viking 2 snapped some pictures showing early morning frost, showing that there is still a water component to Martian weather and geology, but it's very slight. So what happened with that life detection? There were 6 different experiments that they carried to try and answer the question, does Mars have life? And they really were looking for like current life, still active life. And some of the tests came back what appeared to be positive. And they got a little excited, but then some of the tests came back a very strong negative, and they were kind of scratching their heads. And when they really considered what the landers found, more detailed information about the conditions on the surface, and also we were at the same time learning a lot about the extent of Earth life. Remember, it was just in 1977 that we discovered there was life on the deep ocean floor. Kind of take that for granted knowledge now, but as I was saying earlier, it's like sometimes you have to remember it was not that long ago that we had there was a whole ecosystem to Earth that covers 70% of the planet that we knew nothing about. What we eventually discovered was that a lot of the tests were flawed that Viking carried. A lot of them did things to the sample that we were like, wow, if there was life, that actually could have killed it, or that could have been lifeless soil, but at doing that to it could have produced a false positive. So most of these actually got explained away as likely false positives. Most of them ended up getting discounted, and overall the life detection results of Viking are considered inconclusive, which means a big so it's not that Viking showed there wasn't life, it just didn't show there was. Thankfully, we realized the error of our ways. We realized the hubris and that we really put the cart before the horse on this one. And so we took a step back, and we didn't, unfortunately, go back to Mars for over 20 years. People were really soured on it because it was like, well, that's disappointing. But we realized maybe we were asking the wrong questions. So we took a step back and said, let's try this from a different view. And we developed the Pathfinder mission, which landed in 1997. And we can see the landing system it used was an airbag system. It would inflate all these huge airbags made of Kevlar and would be dropped from several meters above the surface after being slowed down by a parachute and some thrusters. And then it would bounce and roll and eventually come to a stop and then open up like a flower, basically. The tetrahedral shape means that no matter which side it landed on, when it opened itself, it would right itself. And so we can see a view looking down. Now, this mission, literally Pathfinder, right, was supposed to be the first in taking a step of back it up. Was Mars ever more like Earth? Specifically, was there ever a lot of water on the surface of Mars? We saw features on the surface from orbit that looked like rivers, but maybe they were carved by lava, right? We saw things that looked like canyons, but maybe they were mostly wind carved, right? We didn't have enough evidence to conclude that. Now, Pathfinder also carried with it a very important piece of equipment, the little rover named Sojourner. And it's about the size of a microwave. This is very much like what that helicopter Ingenuity is. It hitched a ride on this mission to test out that question, can we have an autonomous mobile spacecraft on the surface of Mars? Now, we had done this on the moon, right? We had rovers on the moon that were, and other than the ones driven by the astronauts. The thing is, though, the moon, it takes a little over a second to get a signal to the moon, but it can take anywhere from 4 to 21 minutes to get a signal to Mars. So that's a very different game. There is no joysticking this. There is no real-time control. We need to know whether we could invent something smart enough to drive itself. Thankfully, this rover drove off of its pad and drove up to rocks and was just a huge little success. And here we can see what little film exists. This was cutting edge technology. These are early 90s cameras, folks, all right? It worked. It worked amazingly well. And one of the things that I am gonna do, let me make sure here, there we go. I want to have more, there we go. All right, so what I'm going to do here really quick, I am going to pop in a couple of videos. And I'm going to pop the first one in here, and I don't want you to click on it now, but I want you to, at the end of the talk, make sure that before you leave this meeting and before it gets shut down, that you click on these links, or maybe click on it now and pause it and have it open and ready for you. The video I just put in there is someone took all of these little still shots of this little rover and actually used really amazing video processing and artificial intelligence to create a very smoothed out little movie of this rover driving around on the surface. And it's just adorable. It's so cute. And it's really amazing to see people take, past data and do something, modernize it and make it look like the data we get nowadays. So yeah, the rover worked great. So the general idea was, let's build bigger rovers. So here you see our rover family portrait, and this is the small rover. You can see Sojourner sitting there, and then on the left, we see the next rovers we built, the Mars Exploration Rovers, MER, Spirit and Opportunity. And then on the right there, we see a model of the Curiosity rover, which landed in 2012. So the era of the Mars rover began. And since Spirit and Opportunity landed in January of 2004, we have had at least one rover operating on Mars ever since, oftentimes two. So of course, Spirit and Opportunity were both in operation for the 6 years that Spirit lasted. And then Opportunity continued. And then when Curiosity landed in 2012, we were back up to two. Opportunity, of course, the little rover that could. She's my baby. And yes, I named my first child after her. She's not named Opportunity. Her name is Toki, which means top time of opportunity. She lasted for nearly 15 years. And it's important to remind ourselves, because I was on this mission from the very start. I was there when they were being built, is when I came into it. We had that mission planned as 90 days, 3 months. That's what we were hoping for. So understand that when we landed, it was like mad dash to do stuff, like hurry, check everything out, hurry, we got to drive, we got to go see that, we got to do this science, because we literally approached every day as if tomorrow we might die. And even if we don't, we're only going to be here for 3 months. Maybe we'll get a little longer. You know, the engineers are very talented. But if you had told any one of us at that point in those early days that they would last more than a year, we would have been like, yeah, no way. There's solar power. The solar panels are going to get dusty. They're going to die. It's going to be all over. If you had told me that opportunity would have lasted almost 15 years, I really would have questioned your sanity. So the longer these rovers lasted, the more we just were absolutely amazed at the job we did. And if you want to know how they possibly lasted so much longer than we thought, there are a lot of things that went on. One of the main things that happened, of course, was those solar panels, though they did get dusty, would also regularly get cleaned off. And I could tell you the first time this happened, it was a shock. Things were getting pretty bad. Our power was getting low. They were getting pretty dusty. But we'd already lasted longer than our 3 months. It was about 6 months in. And we were like, I think the end is near. But wow, what a ride. Twice the mission length. It was good. And then one morning we came in and the engineers just came running up to us and said, wow, you'll never believe this. And we're like, oh, we're scientists. We see amazing stuff all the time. And they said, no, you're up to full power again. And literally we were like, no, you're right. We don't believe you. That's impossible. And sure enough, it was true. And sure enough, when we took a picture of the solar panels, they were clean. And yeah, we spent some time scratching our heads saying, what just happened? Well, it turns out that Mars has wind, though it's not very strong wind at all. The strongest gust on Mars is only like a 10-mile-an-hour breeze here on Earth. But it also has dust devils. And it turns out that those dust devils are common enough in the spring and early summer that, one every once in a while can hit the rover. And it turns out that it's like a vacuum cleaner. It cleans the rover off. Well, this kept happening. And once we realized it was going to keep happening, that's when we started to wonder, are we actually looking at a multi-year program, not a multi-month program? The other thing I think played a big role in these rovers lasting so long is truly just the human emotion of not wanting to let go, right? I mean, if you have a loved one who's got a health issue, you do everything you can. You don't care how improbable or how crazy it sounds. And we take that same approach with these robots. We thought, okay, if this happens, that'll be mission end. And when you're planning the mission, that sounds reasonable. But when you're on the mission and your, career and emotions are vested in this thing, and you start running into, well, mission end, and suddenly you're like, you just don't want to accept it. And you start thinking of things that you never would have thought of because you've got that emotion behind it. So I think that that's honestly a big reason of why these rovers lasted so long. So this is kind of where we are currently. This has been a whole long string of both orbiters and landers that, as I said, over the slow process of nearly 2 decades now, have answered definitively, yes, Mars was once warmer and wetter. We have found that looking at physical evidence. We have found that looking at chemical evidence, looking at climate evidence. There's just no other explanation for all the things that we have seen. So finally, after all this time, we decided we were ready to go back and try the thing that we originally wanted to do with Viking, which was life detection. Thankfully, by now, we were much wiser and far more aware of this idea of life detection isn't easy. On Earth, usually you see something swimming or crawling or flying, or you bring a soil sample to a lab, put it under a microscope, you see little bacteria swimming around. It all sounds easy. But when you're looking at a planet that may not have had life for 3 billion years and you can't be there yourself, suddenly the trying to determine whether there was once life there is no small task. So that is the main thing we want to talk about with this. So here we are. We know that this was once Mars. We know this is not Mars anymore. We have a pretty good idea of why this happened, but we don't know whether it had life, and if it did, whether any of that life has survived today. One thing we see about Earth is that once life takes hold, it seems pretty hard to get rid of it. We've had 5 mass extinction events on Earth that have wiped out 80, 90, 95% of species, and life came back and looks the way it does today. So if there ever was life on Mars, and if it really got a good foothold, yeah, there is a chance that maybe deep underground where it's still warmer and there's still probably some liquid water and it's shielded from solar radiation, there could still be probably some microbial life hanging on. It's probably not accessible to something like this rover, which is why I don't necessarily think this rover is going to be able to find current life, even if it's there. So here it is, mission goals. Let's go through them really quick because this gets a little dry. This is very technical speak, but I like stories. So yeah, geology. We're always interested in geology, and the more we learn about geology of other worlds, honestly improves our knowledge of geology here on Earth. And the nice thing about this rover is we can study geology both on the large scale from orbit, like the kilometer scale, or the meter scale with a lot of the cameras, looking closer at the centimeter scale, and even down to the millimeter scale. So we can do both the very large and the very tiny with all of our missions. But here it is, astrobiology. Yeah, that's a thing, and it wasn't a thing 30 years ago. So this is the idea of we're trying to determine, we know now there were habitable environments. Now we got to answer the question of, were they inhabited? So yeah, that's what we're looking for. And then of course, collect samples, right? Never done this before. So this is the big thing of, we're going to collect those samples and store them. We're going to drop them off. Then another mission is going to come with just 2 components, a rover that we call a fetch rover, whose only job is to go drive, find the samples and pick them up, and a small rocket that the rover will put the samples into and whose only job is to launch the samples and get them into orbit around Mars. Then another mission will come, catch them from orbit and send them back to Earth. As I said, I don't have a date to tell you when this is all going to come back. So the 4th goal, though, that we don't want to forget is that we are sending people to Mars, right? We are going to do that. It's just a matter of when. And so this rover actually also was tasked with helping pave the way for that. And it does that in a couple of ways that we'll talk about. Let's quickly talk about where we're going. Here's all of our past landing sites, and then we can see big there, Mars 2020. We're going to a place called Jezero Crater. And let's talk about why we picked it. Okay, first of all, it's a crater, as the name implies. As you can see, it's a crater that's about 40 kilometers wide. And the black circle there is our landing ellipse. And I can tell you, I didn't mark it on here, but I'll bring my cursor over here. We landed right there. So we nailed it. Now that landing circle you can see is less than 10 kilometers wide. And that's because of the new landing system that we were able to invent. The Spirit and Opportunity rovers, their circle for landing would have encompassed this whole crater. It was 160 kilometers wide. So that was the accuracy we had back then. So we never could have landed at a place like this with those. So we can only land here because of this new landing system. And what really stands out also is right here. We see a channel that comes in and a fan-shaped delta. And then we see evidence of, whoops, I didn't mean to click on that. Let's go back for a second. And then we see evidence of a shoreline. And then we even see a channel up here that's higher in elevation. So this was probably an outflow channel. In other words, this thing was once a lake. And it was filled with water long enough, high enough to break through and flow out. And didn't just drain all at once, right? This is a canyon that was carved over a long period of draining. So it was probably still being fed as well, and also around long enough to form a delta deposit. So this was not some flash flood event. This was a long-standing lake environment. And so let's just take a little bit closer look here at the terrain. As I said, we landed pretty much like right there. Yeah, right there, right where my cursor is, right there. So our plan is we're going to drive. They're looking at a few routes, but I think the route they're going to take is they're try and drive by this little butte here, which is probably a leftover piece of the delta that's just extra hard and hasn't eroded away. And then we're going to drive along the edge of the delta. It's kind of steep. We can't drive up over it there at least, but we're looking for a way to safely drive up onto the delta, and then eventually looking at exiting and going and exploring this outflow channel. So this is very different from working on the Spirit Opportunity rovers, where we didn't know where in this 160-kilometer circle we would land. And so we couldn't plan a drive ahead of time. We had no idea where we were going to drive till we got there. And we literally decided that day to day. But this one, we've already got the drive planned out because we know exactly where we're going to land. So it's quite remarkable progress that we've made. Now, I would show you all of these cool CGI perspectives of the landing process, but I'm actually, and I did that before when I gave this talk before the landing, but right now I'm just going to show this, which shows you what we call the 7 minutes of terror, which is what happened on February 18th. And one thing you'll notice about this is that we hit the top of the atmosphere. That's right up here, entry interface. At that point, we are going about 12,000 miles an hour relative to the surface. We get 7 minutes to touch down gently, 0 miles an hour, and that is it. Now, you also will remember I said it takes 4 to 21 minutes to get a signal to Mars. At the time of this landing, the delay was 11 minutes and 22 seconds. So it's not that hard to do the math and realize that by the time we heard that we had hit the top of the atmosphere, it was already on the surface for at least 4 minutes, either healthy or in many pieces. And that is a very sobering thought. And trust me, every time I go through one of these and I hear entry interface, that's immediately what my mind thinks is, oh my gosh, we've already landed and we're just waiting. And yes, that means there is not one thing that we can do from here on Earth to help this process. All we can do is sit here and listen and wait. Now, back in the day, you would get what we got with this telemetry, right? We get speed, acceleration, altitude, confirmation that the parachute has deployed, that the heat shield has been deployed, and all of these factors. But that was all you ever got. No pictures came back till this was all done and you were on the surface. But for this mission, we put so many cameras on it that we included many cameras that would not just take pictures of this landing process, but high definition video of this landing process. Now, once again, I am not going to show this video. I wish I could, but my experience is that sharing videos over Zoom, they can be choppy. And I just don't want you to see it that way because it really doesn't do it justice. So this is another one where I am going to grab a link that, again, I encourage you after this talk is done to go and watch this. And like somebody commented like, oh, that must be CG because we're not really there. You're absolutely right. But what this video is that I encourage you to go watch, keep in mind as it happens, it's real. There's no CG, it's real footage of actually landing on Mars. And yeah, I was not emotionally prepared for watching this video. I heard it was going to be released. I was watching the press conference. They said, okay, here it is. I was all excited and it started playing and I just started crying. And I think it's because I had been through landings where we never got to see any of that happen. We just had to imagine it was happening, and to actually watch it happening and see it all and realize that's Mars. That's not a test. That's the real thing. It's not a movie. It's the real thing. So needless to say, it all worked absolutely perfectly. So yeah, so far it's important to, yes, note when things are real and not real. So the thing is these images, right, these are computer generated. This is the MSL, that's Curiosity. This is using an actual image of the surface of Mars, but we've CG'd the rover on it, but we actually can take sort of selfies with Curiosity. And you can go on and find those, they're pretty easy. But this one is Perseverance. And at first you might say, that looks like the same rover. All right, we did reuse the basic design, the chassis, the size, the mast. It's big, it's the size of a compact SUV. All right, that mast stands 7 feet tall. Those wheels are 10 feet wide. Some changes that we made, we gave it better tires, because one thing we found with the Curiosity tires is they just got totally chewed up. So we gave it stronger tires. The other thing is completely different science instruments, all right? A lot of things like the same theme, in that we have tons and tons of cameras, even more cameras, more color, more video capability, and spectrometers, things that can use light to tell you what things are made of. I do not have the time in this talk, nor do I even want to go into the details of every single science instrument that is on this rover. With the Spirit Opportunity rovers, I could have summed up the whole science payload to you in under a minute. In order to give you that same level of detail with this payload, it would take 15 minutes at least. It really blows my mind. This thing really is a rolling laboratory. So some key things here, cameras. All right, so the square bits right here, these two are cameras, 2 eyes, so we get a left and right, we get stereo. These are the Mastcam Zs. They are the first zoomable cameras on Mars, as well as the highest resolution cameras that we've ever had. And they were actually worked on by many teams, including a lot of my colleagues here at Cornell. So this is Cornell's contribution. Outside of those, we see 2 circles. Those are navigational cameras, also left and right to provide stereo. In the past, those were always grayscale cameras. With this rover, they're color, so all color all the time. And then up here is something called super cam, and super is the right word. This thing is a camera, 2 different lasers, and I think 3 different spectrometers. And what that does is allows us to not have to drive up and touch a rock. We can tell what rocks are made of from as much as 20 feet away. And we hit it with lasers. One of the lasers is destructive. That means it actually destroys the rock, vaporizes it, and we look at the cloud and we can tell what the rock was made of. But it also has another laser that is non-destructive. In other words, it just lights it up. And what we're looking for there is luminescence. And luminescence is basically when you give something light and then chemical reactions happen, actually little quantum effects happen, and it gives light back, but in a different color. And so you've experienced this, I'm sure, in your everyday lives. One thing is fluorescence. This is like when you shine a black light on something, and especially if you've like watched crime shows and stuff, right? You can do this. So you shine a black light and suddenly something you couldn't see glows, and it does it right away. And the moment you take the black light away, you don't see the glow anymore. So fluorescence happens very fast. And even though you're shining UV, it glows in kind of a blue light. So again, it gives off a different color than you initially gave it. But then there's phosphorescence, which is a long game. That's your, glow in the dark green stars or glow in the dark on a piece of fabric, where you shine it with light and then you turn off the light and it glows for a long time. So we're basically doing those techniques on Mars, and it's a great way to find out what a rock is made of without destroying it, which is kind of nice. All right, we're also listening. We have our first microphones operating on Mars. We have tried to send microphones before. This is the first time we've succeeded. So we do have the first sounds from Mars. I can tell you the first sounds, pretty quiet, actually. That thin atmosphere does not transmit sound very well, and there's honestly not a lot going on. So it's wind, basically, and you can hear the little whir of the motors on the rover. Now it is going to get more dramatic, because one of the things that microphones are going to record is the sound of the laser, the destructive laser blasting the rock, which you'd like to think is going to be the classic pew pew, but no, it's actually probably going to be like a little crack noise, little clack clack as it hits the rock, but we're going to hear it. That'll be cool. And that does give us information about like how strong is the rock, how did it react. All right, now it also has an arm, and here we can see it doing a bicep curl. I hope you get an idea for how big this thing is. This arm is just enormous. The instruments on the end of the arm are big, hunkin' heavy things. So that arm is amazingly dexterous, but also very, very strong. And at the end of the arm is a whole nother set of cameras and spectrometers. And these are for actually going up and touching a rock and getting very close up data and images. And yeah, we love our acronyms. Pixel is a spectrometer, but my favorite, Sherlock. Yes, we managed to build an instrument and we called it Sherlock, and it does stand for something. It stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. Little forced, but we made it work. And so, yeah, it's using more of that luminescence to tell what the rocks are made of. And then Sherlock has a little camera magnifying glass that, yes, we actually call Watson. Couldn't resist. So Watson's going to be able to take up close color images on that very tiny millimeter scale to see what the fine surface is like. All right, so this is the kind of stuff we are looking for, honestly. This is these instruments being tested on microbial mats. So these are things that are commonly found in deltas on Earth, layer upon layer laid down, in which bacteria and microbes and evidence of them being there has been well preserved. So that is the beauty of Jezero Crater. This delta likely has well-preserved rock samples, right? They are well-preserved, but also exposed and accessible. So it's the perfect combination. Something like stromatolites we might find if they existed there. So we know these environments in Earth do a good job at preserving life over long periods of time. And no, we're not done. We also have a radar system that can penetrate several meters down into the ground, possibly tens of meters into the ground, and use sonar to get an idea of what the layers of rock look like underneath us. Yeah, it just feels like this clown car of like, oh, and it also has this. Oh, and it also has this. So again, this rover is probably not going to find life, but what we're looking for are biosignatures, things that point toward there once was life here, chemical or physical features that suggest life. So not actually the life itself. All right, we also have a weather station. Remember, I said we had to pave the way for human exploration. Well, one of the things humans are going to have to contend with is the weather on Mars, the dust storms, the dust, and oh, again, the dust is going to be a major factor. Not only does the dust interfere with communications, interfere with solar panels, it's also toxic to us. So yes, we need to understand better the weather on Mars and the dust. And another instrument on it is, I think, my favorite named instrument, yes, even better than Sherlock, is MOXIE. MOXIE is not a science instrument, it's another engineering experiment, and it's going to try to turn the carbon dioxide, which makes up almost all of Mars's atmosphere, into breathable oxygen. Also, that same oxygen could be used for fuel. So both for breathing and for fuel, O2. And you think about it, CO2, it's just a matter of trying to get the carbon off and just get O2 out of it. So we're going to be trying that one out. It's basically a robotic plant. Okay, well, then we have the sample collection system. So this is the thing that once the drill collects the sample, it's going to put it inside the rover. The rover is going to go through some initial measurements, but very non-destructive. We're just going to measure some basic things about it, and then we're going to seal it very carefully. Those tubes are the cleanest things we've probably ever created on Earth, because the last thing, of course, we want is Earth contamination in them. We really want to know what Mars is like, not Earth. So they're extremely cleaned where the samples are going to go. And so that is pretty much the whole mission in a nutshell. Oh, yeah, and the Ingenuity helicopter. All right, yeah, this thing just has so much stuff on it. So now, before I open it to questions, the one thing that this talk, unfortunately, because everything's been so crazy, lacks is any of those real images like you see behind me. So I'm actually going to go in here. I'm going to be switching my share in a moment. All right, I'm going to do that. And there we go. Boom. So now you see something similar to what's behind me. What you're viewing here, this is the full panorama in full high resolution taken by Mastcam of our landing site. We have now completed our 3rd test drive. So let me zoom out here to give you an idea of this thing. Now you'll look up here in the corner, you'll notice that there's a little red box. There's a box and a little red box. That's showing the part that we're looking at. So this thing goes 360 degrees all around us. And you can zoom in and really get an appreciation for the resolution of these images. And you can just scan through here at this amazing landscape that we've landed at. And okay, let me zoom out a little bit because I want to get around to showing you. This thing's so huge. All right, so what do we got here? Down out in the distance there, you see those mountains in the very distance. That's actually the edge of the crater. Then what we start to see here in the foreground, these closer hills, that's the delta. And we can already see some layers in it. That is that delta. We see some exposed layered rocks in there. And again, that's the edge of the crater behind us, the delta in the foreground. You see a sand dune there. That might be some hazards. There's that mound I told you about that was that one little dot of delta left behind. You can see that the crater rim is very close now. We can't see the sky anymore in this particular view. And I will put the link to this. I'm going to grab the link for this right now and also put that into the chat so that any of you can go and do what I was just doing, pan and zoom around and take a look at our new home on Mars. Now, you might also notice that what I didn't have in that talk was any science results because we don't have those yet. So unlike Spirit and Opportunity, where it was just this mad dash, we might die any day, and even if we live, it's only 3 months, do. This one, Curiosity, has lasted 8, almost 9 years now. We're much more relaxed. So and also it's a much more complicated beast. So we're still in the stages of testing all the instruments, making sure nothing broke during the landing process, calibrating the instruments, making sure that the results that they are giving at their test targets are the same ones we were seeing here on Earth when we were testing them. Checking out, we just did, like, we wiggled the wheels and did our first drive last week. Science is probably not going to start in earnest for probably another few weeks even at this point. So it's a complicated beast, and we also have a lot more confidence in our engineering. So other than really beautiful images, which I certainly encourage you to go and check out, no science to report just yet, but I expect amazing things from this mission. Though, I'm not necessarily holding out hope that we'll find life with this rover, but I think we're probably gonna get a lot of answers on, do we think that it's likely that there's life here, or does it look like this is just, nope, all the things are there like Earth, but doesn't seem to have ever gotten life. Oh, I see a question. Where can we get the rover fabric that you're wearing? All of a sudden one knows, like, okay, so yes, if you've ever seen my talks, you know that I always have like a shirt or a dress for the occasion. I'm in a professional capacity, so I don't want to take this as like me giving a commercial, but yeah, all of my science nerdy clothing comes from a store called Svaha. I will type the name here. There, and it's an online store. It's really, they're eco-friendly, they're worker-friendly, they pay decent wages, and their stuff is super cool and high quality. And it's not just science, it's not just STEM. There's stuff for like literary nerds on there, history buffs. I mean, pretty much you name it. If you can geek out over it, there's probably something there for it. They have stuff for the whole family, and it's comfortable and high quality. One of the things I love about it is that it's all made of kind of a t-shirt material. This one's even a little stretchy, so it's really comfy, but like you can fold it up and put it in a suitcase, and then you get there, you unroll it, it doesn't wrinkle. It's magnificent. And all of the dresses, and they make leggings too, and everything has pockets, and not just like little usable pockets. So if you've ever seen me, I always have a ton of stuff in my dress pockets that I can just like pull out, like, hey, all the stuff in my pockets. I don't carry a purse or a wallet I just have my Svaha pockets. So yeah, whatever you're into, oh yeah, that's the website. Whatever you're into, you can find it there. And they have, I don't know if they, some things are like special issue. I don't know if they have any of these shirts left, but they have new stuff there that's rover themed. They have the parachute. When you watch that footage of the landing, you'll notice the parachute has an orange and white pattern to the parachute material. And a lot of people started asking immediately about it, and it's not random. It actually had a secret coded message in it. And I'll let you guys know what the coded message was. It was the JPL mantra, dare mighty things. That's what the message was encoded in the parachute material. So questions about Mars, about what's coming for Percy. Oh, and the coordinates, yes. And around the edge of the parachute is also the coordinates of Jet Propulsion Laboratory where the rover was built. What's one science result that you think is highly likely and would be surprised if it wasn't confirmed? And what's a result besides direct observation of life that would be highly unlikely, but you're hopeful for? Woo! Oh, that's a lot to process. I think the thing that, let's see here, I got a two-parter, highly likely. I certainly think it's highly likely that we are going to confirm that this feature was in fact a delta formed by a river entering into a long-standing lake, and we're going to find an ancient shoreline. There is, I want to make sure I get this name right. There is a lake, and I'll pop a link. There is a lake in Turkey, I think. I want to make sure I get this name right. There it is. So there's a lake in Turkey, there's the name Salda, Lake Salda, and I'll put this into the chat, that we think is really what Jezero Crater once looked like. So you could even go, you know, if you were a world traveler, you could go and see this lake once the pandemic is over and have this sense that you're walking around. And so that's been a great roadmap for us of like, okay, and looking at the life that exists on the deltas in this lake, you know, helping that inform us, what are we even looking for? Because that's the problem of astrobiology, what to even look for. So I totally expect that our measurements on the ground are going to confirm that this is what we think it is. But keep in mind, like, you know, we still have that as a hypothesis. So that needs to be tested. Something that would be unlikely, but I'm hopeful for, I will just say something that we think might be life, but you want besides a direct observation of life. I think maybe a surprise about the age. One thing we don't know about this delta is we don't know how old it is. We don't know when it formed. We have like, we think it formed in this broad range of time, which is not very specific. And one of the problems is the rocks that we think make up something like the delta are not the kind of rocks that can be easily dated. Because they've been chemically altered, they're sedimentary, but the floor of the crater appears to be covered in a volcanic layer from eruptions that happened after the lake dried up. Now, that's nice because if we can sample that, even though that's not a sample we would necessarily expect to find life in, volcanic rock can be dated because it comes out of the ground, it forms, it freezes, and then it just sits there. So it really preserves a lot of information that could help you determine when it erupted and was deposited there. And so if we can get that back on Earth. So one thing that I might be interested in is maybe finding out that Mars was geologically active a lot longer than we usually think. So I'd be interested, I think it'd be really cool if we could find out that that volcanic floor was a lot younger than we thought it was. So that is one thing I'm very interested to find out, is to see if we can get rock back that would allow us to date that bottom. All right, any other questions?
There was an earlier question. Are there relatively stable areas with magnetic field protection? I heard Mars has a lumpy magnetosphere. Might life do better there? Toughie.
So Mars does have localized magnetic rocks, but it does not have a magnetosphere in the sense that Earth does. It does not have a planet-wide magnetic field to it. We know that it did. We have from orbit been able to detect the rocks that are old enough to have preserved that magnetic field. We do this on Earth. This is how we know the history of Earth's magnetic field. So we see that on Mars. We know it did have a magnetic field like Earth's that was protective. And we really think a big driving force of the huge climate shift in Mars and possibly the extinction of life, if it was there, is the loss of that magnetic field. And that exposed the atmosphere to being stripped away into space, and also the planet cooling down, and you stop that volcanic activity, you stop replenishing the atmosphere, you lose the heat that's generated by that, and the whole planet just kind of dries and cools off. So the only real way to get protection on Mars nowadays is, as I said, to go underground. About 5 meters of Martian soil will provide you about the same protection that we enjoy on the surface of the Earth right now. So one of the things that we would say, like, does that mean we have to build a colony underground? Not necessarily. One of the cool ideas that's been proposed is that we try and build the habitat for us to live in before we even get there, and that we send little rovers that can, with 3D printers on them, and we've done this, that can literally use the Martian soil as a material to 3D print with, and can 3D print a whole like dome made out of Martian soil that would protect us from dust storms and from solar radiation. And then inside of that, we could build a nice light inflatable actual housing to live in. So the materials are there to protect us. We just have to be able to utilize them. And that's why also we think if there's still life there, deep underground, several meters probably, is the most likely place we would expect it to still be clinging on to existence. We think there's a lot of evidence that there still is a groundwater system on Mars, and the deeper you go, the warmer it is. And so it's got all of the conditions. We know that you can go a mile down in Earth's crust and find lots of life. And some people don't realize that, like, you can go a mile down in the crust, you can go up to the top of the atmosphere, you will find life on Earth. And so it's possible, yes. When we would be able to actually access something that deep and actually test it for life, that's probably not anytime soon. Are we certain that everything we have sent to Mars is sterile? Yes, I mentioned the whole tubes are clean. Is there any chance we are contaminating Mars with Earth-derived organisms? Sadly, I must answer yes. There is a chance that we have done that. Planetary protection is a whole division at NASA, and we take that very seriously, and this is exactly what they are in charge of being concerned about. Yeah, if you're trying to go and find life on Mars, bringing Earth life with is a bad thing. And also the fact that we have no idea how those two bits of life would interact. Wouldn't it be awful if we brought Earth life and it killed off the Martian life? And remember, Mars isn't the only place in the solar system that we think might have life. So life detection also comes with this challenge of planetary protection, that we don't have this contamination. There's also the question of when those samples come back to Earth, how do we protect Earth from possible Mars microbes that could be in those samples? So this is a big consideration, so that we do everything we know to sterilize all spacecraft before they leave Earth. The reason that the Cassini spacecraft was crashed into Saturn and vaporized in its atmosphere was so that we didn't risk contaminating one of its moons that we think might be habitable by it crashing into the moon when we lost control because it ran out of fuel. So another thing that we do is any spacecraft that has landed on Mars has now kind of a no-go zone around it, that we are probably in the future forbidden from ever doing science, especially life detection science. Our hope is that even if we brought with a couple of microbes. And even if they survived and got into the Martian soil, that it's such an inhospitable environment to Earth life. Maybe there's Mars life that's fine with it and has evolved to handle it, but it's so inhospitable to every Earth life that we know of that anything that managed to survive and get into the Martian soil on the surface would not be able to spread very far. But no, the chances are not zero. So we have safety zones marked around all our landing sites and all the places that rovers have ever driven. They're very clearly designated as these are places that we avoid because we don't want to further contaminate. Sending humans has a whole host of additional problems because, you know, we're just big balls of life, not just us, but all of our microbes. It is a challenge. It is something we think very seriously about. And as I said, those sample tubes are the cleanest things we have ever created on Earth. We're pretty sure there's absolutely nothing alive in there. But I will tell you that there are a few bacteria whose species name actually has Jet Propulsion Laboratory into it because they've literally been created. They have evolved within the sterilization chambers at Jet Propulsion Laboratory in this endless arms race of we develop better sterilization, but that one microbe survives it and passes on its genes to the next generation of being able to survive it. And now we've got a new species that is able to survive it. So now we got to come up with a better sterilization process. And this has actually created a few new species of bacteria in this effort to completely sterilize. So yeah, it's a challenge. It's a factor we have to acknowledge. It's one that we hope we've done enough to mitigate any negative effects of. But yeah, it will always be a question. And there's the problem also of we're not the first ones to contaminate Mars. So, you know, don't get upset about us. Mars and Earth have contaminated each other since their creation. Impacts have exchanged material. We do have Martian rocks on Earth right now, but we haven't brought them back in a controlled fashion. They've come to us as meteorites. So we have found meteorites on Earth that when we analyze them, it's pretty clear it's not an Earth rock. It is also not a space rock. We know what those are like. It's definitely a Mars rock. And therefore we know that there's Earth rocks on Mars. We actually found the oldest ever Earth rock inside of a moon rock brought back by an Apollo astronaut. So stuff floats around the solar system. And we know that the planets have exchanged material, which has brought up the issue of what's called panspermia, the idea of if life started on Mars, Earth, or Venus, could it then have spread by this exchanged material to the other planets? We might all be Martians. We could not rule out the possibility that life actually started on Mars, transferred to Earth, died out on Mars, and flourished here. And so finding life on Mars, the first thing we're going to start asking immediately is it Earth life? Is it the same genesis as whatever started our life? Which, yeah, we still don't know. And what can that tell us? And so we're going to be looking to see if we can tell if it's truly something different. And I fear, honestly, that any discovery of Mars life is always going to come with this bit of this asterisk of could still be the same origin as Earth, whereas going to the outer solar system, moons of Jupiter, moons of Saturn that have habitable environments under their surface, oceans. If we were to find life in an ocean around Jupiter that's under 6 miles of ice inside of a moon, yeah, then there's no chance of panspermia, right? There's no chance of exchanged material. That life is almost certainly a separate origin of life. But with Mars and to some extent Venus, I think this is always going to be a question. So unless it was like so vastly different, there's always, yeah, going to be the question of, has that contamination actually already happened? But yeah, that's a great question. I'm always glad when someone brings that up because I get to talk about planetary protection. And yeah, it's a thing we think a lot about. Oh, Ingenuity's range. Batteries. Okay, yes, Ingenuity. Its first test flight is literally going to tell it to fly up a few meters, probably like 10 meters, and hover, take a picture, and then come back down. Its full range, I have not heard. I think that they didn't want to put out a number because they're just basically going to keep on flying it a little farther and a little farther. Ultimately, you're right, battery is going to limit how far it can fly. It does have solar panels on it, so it can recharge itself. It's never going to come back and land on the rover. There's no way we would risk that thing crashing to the rover. The rover's going to set it down on the surface and it's going to drive away, and then the two are never going to come near each other, hopefully ever again. So Ingenuity has to kind of do its own thing. But yeah, it should be able to definitely fly on the order of tens of meters, maybe even 100 meters or so in one go. I think they have not wanted to put out hard numbers because they just, like I said, it's a first time and they're just going to try a little bit more each time and we'll see what happens. We were also told that like the Spirit and Opportunity rovers would probably not drive more than like 20, 30, or maybe 40 meters in a day. We ended up pushing those things to sometimes drive 120, 140 meters a day. So even if we were to put out numbers, they're going to push it past that. You know they are. Oh, how does Ingenuity communicate? Via relay. So communications on Mars, of course, are tricky for a lot of reasons. You got the light travel time delay, but you've also got the issue of this isn't like a constant Wi-Fi connection. We are not in constant contact with the spacecraft. The Deep Space Network has dozens of things in space that it's trying to maintain communication with. And so you got to get your time. So we typically only have a direct connection with the rover for a few minutes a day. And Ingenuity is probably going to do what Percy does most of the time, which is to relay information to one of the spacecraft that are in orbit around Mars. So we actually have five. Wow, we had 4, but now I think we're up to 6 because 2 other spacecraft arrived at Mars this summer, one from China and one from the United Arab Emirates. So we have a lot of stuff around Mars, but for NASA things around Mars, we have 2. So we have relay so they can talk to those satellites, and then those satellites using much more bandwidth can talk to Earth. And it's a lot easier to do it that way. So I believe that Ingenuity is going to relay information to one of the Mars orbiters. I don't think it's going to go to the rover and then to the orbiter. I think it's just going to talk to the orbiter. I'd have to check on that though, but yeah, there's a lot of relay with all of this. Yeah, direct to Earth does work from the rover, but it's not ideal. The orbiters, of course, if you never have to land, you can have a much bigger radio dish. It can be a much bigger craft. I mean, this rover is the size of a compact SUV, but Cassini was the size of a school bus. Generally, orbiters are larger because we never have to worry about slowing them down, landing them on a surface. So they can generally have a bigger receiver and bigger antenna and bigger transmitter. And the rover, of course, is closer to the orbiter than it is to Earth by many, many orders of magnitude. So it just makes a lot easier process. But yeah, we normally only talk to the rover twice a day. We typically send it up new instructions in the morning, and it sends us, a little bit of leftover data from the day before. But then in the afternoon, toward the end of its day, it sends down a bunch of data that it collected that day, plus maybe some backlog stuff from previous days. And yeah, how many minutes you get each of those times depend on what's going on with the Deep Space Network and how much time you manage to get, because they got a lot of things to talk to out there. So the rover and the helicopter have to be able to do most of what they do all on their own. Just basic set of instructions, and you let the spacecraft do the rest. I love the start out. Is it true that? CPU on the rover, yes. It's the same as a CA2000 iMac. Do not honestly know the specs of the onboard CPU. I would have to check on that, and I can certainly get back to you on that. Yeah, CPU equivalents. I will say that again, it's this, yeah, I mean, you do have to think it has to be robust enough to survive a launch, survive space, survive a landing, and then survive long-term on Mars. There's also, again, remember the issue of you are locked into when you built something. So a lot of people often, like toward the end of the space shuttle program, marveled at how incredibly out of date the control panel and the computer systems on board were, but it was it was designed back right in the late 70s and early 80s. And we take for granted how quickly, like every few years, you buy a new phone and a new computer. But keep in mind, we send a spacecraft out, as I said, from when you decide this is what we're going to put on it to when it arrives, typically 5 to 10 years. And then you're going to spend probably, hopefully, another 5 to 10 years using it. So, you know, by the time Cassini died, the things on it were the pinnacle of technology 30 years before that. So yeah, Mars is one of the quicker ones, right? It only takes us 7 months to get there, and we're getting really good at designing these rovers so that we can churn them out a little faster. But yeah, there's always going to be, what you have on hand in your room is certainly more up to date and more powerful than most of what's out there floating around in space, because of the nature of that lag that there is nothing we can do about. Can you imagine any discovery on this mission that would mean we cannot colonize? No, I don't think there's anything we're going to find out about Mars that is profoundly different enough from what we already know to cancel that idea completely. I will also say that we're not ready to colonize right now. And I'm not a fan of using the word colonize, because I think that people have different ideas of what that means. I prefer the word explore, because that way we can start out with beginning missions that are going to be small and relatively short, and then we can build to longer stays like what astronauts do at the space station now. A colony, then I start to think about like a permanent settlement where people live out their entire lives. People are born and die there, and they never come back to Earth. And I think that is still in the realm of science fiction. We are so far from that I don't think that that's really not in any of the minds of the scientists. And there's even the question of, is that even something we should do? While I totally think we should go to Mars and we should use human exploration to learn about it, whether or not it makes sense to create permanent residence there is still, to me, a question to be debated. We're not even ready to go today. A lot of people say, like, how long until humans go on Mars? And I say, I can't really tell you, because we'll go when it's safe. And ultimately, we are still developing the technology to keep us safe. There are still obstacles to safety that we do not have a solid answer for. We're working on it. And we cannot tell you, oh, and we will definitely have a solution in 5 years. That's not the way science works. If you know anything about the James Webb Telescope, you'll know that it's still sitting here on Earth. It's supposed to launch October of this year. Its original launch date, I think, was 2006. I know that sounds bad, but it's also the thing of, like, this is an enormous space telescope that's going to blow Hubble out of the water. We weren't going to launch that if there were something wrong with it, right? It's not worth risking just the whole thing going down the tubes and losing it. So ultimately, when things get delayed in space exploration, it's not because somebody messed up or somebody didn't work hard enough or wasn't smart enough. It's always because we're always trying to do these brand new things that are, no one's ever done before. And we encounter problems that we just can't anticipate. And it's better to sit back and say, whoa, let's redesign, let's make it better. Let's not have that happen on the actual mission, than it is to try and push ahead and still meet a deadline. So I'd like to think that if we could throw infinite resources, like if the government said you can have all the money you want to pursue humans, setting foot on Mars, I think 10 years would honestly be the best I would hope for from this time. I mean, I look at the Apollo program, that was the time frame, right? So I think that we probably could. The problem is you can throw infinite money at it, but there's only so much you can actually use. It's not, there comes a point where we're like, we've got all the people working on it who possibly can, and throwing more money at it won't necessarily make things go faster. So I'm hopeful that I'm going to see it in my lifetime, both hopeful for how long I think I'm going to live and hopeful for how well the technology is progressing. I think there's a very good chance of that. I think there's a very, very good chance to see someone walk on Mars. But yeah, it's not something that I think we can put a firm date on. Is there a plan of autonomous remote laboratory mission to Mars instead of bringing samples back to Earth? I will say that these rovers are pretty much like laboratories and just put on wheels. While it is true that, yeah, there's, you could think, well, maybe there'd be instruments that we could send if we weren't restricted by something that had to fit on a rover and survive driving around and that ruggedness. But keep in mind, it would still have to survive a launch and a landing. So anything tough enough to do that can probably survive on a rover. And why sit in one place when you could be mobile? That was the whole reason that we moved away from landers and went to rovers. And so the idea of building like something the size of a building laboratory where robots would work to analyze things, that's not a bad idea. And it would be a way to limit humans needing to be on Mars, but I still think that something that complicated is probably going to want humans at least involved in the setup of it. I think it's a cool idea as a way that we could kind of leave a laboratory running and have the humans come back to Earth and it could run and then they could go back and check on things in a while. And I think there's a lot we can do with robotics. There are people that then ask the question, can we just never send people to Mars? Can we just do everything with robots? And it's a nice thought to some extent, right? It's nice to think of never risking the life and never spending the extra money to send humans. But I can also say that we still do not have robots that can duplicate a human. And one of the frustrating things that happened when we landed Spirit on Mars is one of my clear memories from being there in the science team room. As we were debating the hills that got named the Columbia Hills, actually in memoriam of the Columbia astronauts, and they were a little over a kilometer away from our landing site. This was a mission that we hoped to drive 600 meters. So looking at something that was 1.2 kilometers away, that's twice the drive distance that we expected to get out of them. It seemed so far away. It seemed like maybe if we're lucky, we might reach that, but it just seemed like a pipe dream, honestly. And we're sitting here debating on whether we go for it or whether we just try and do what we can here and not risk it. And finally, one of the scientists who was a field geologist, so someone who's used to just going out and going and walking and traveling to it, just slammed his fist down and said, if I were there, I could get my jogging shoes on and be there in a few minutes. And we all just kind of stopped and we're like, oh my God. It's just like the perspective of like, if we were humans, this would be nothing. So I think the humans are necessary. And then there's just the fact that the human spirit wants to go. And I don't think that that's a bad reason. So I do think we should definitely utilize robotics. We're getting better with it. And space travel is risky. And I do think it'd be great to maximize what we can do with autonomous robotics. I don't think that's necessarily going to replace humans, but humans are definitely going to have robots helping them, right? They're going to have rovers. They might even have a fleet of Ingenuities flying around, surveying things for them. So yes, I'm always excited when I see like robots now doing acrobatics and cool stuff. And we're definitely going to have robot helpers up there. Okay, so what about if instead of bringing the samples back to the Earth, we brought them to the space station? This has been proposed. There has been serious discussion again about what is the danger in bringing Earth rocks that are in pristine condition, not ones that have blasted into space and floated through space for billions of years and then crashed into Antarctica. Pristine samples directly from the surface and bringing those back to Earth. What kind of contamination and containment is necessary? And this is a hard question to answer because you're talking about creating a containment and safety protocols for potentially an alien life form that you have no idea what it is. In other words, like you asked, like, well, what will kill off a Mars bacterium? No clue, right? So it has been proposed that maybe, someplace like the International Space Station might be a good first analysis. Again, the problem there is that limited resources, right? They only have so many instruments. I mean, it's an amazing achievement. They have huge laboratories there, but still only so much stuff. They are really not equipped to do the kind of astrobiology that we'd be looking to do. But like I said, these samples aren't coming back probably for at least like 15, 20 years. So we've got time to think about that. And we've got time to think about, do we want to build an attachment to the space station that would be able to do initial analyses before we actually land them on Earth? So trust me, there are people asking these questions and wondering, like, what are the safety protocols for doing this? Because we have brought moon rocks back. We have brought asteroid samples back. We have brought just dust from around the solar system back. But this would be the first time we brought a surface of a planet back that could potentially be habitable. Let's remember that even with Apollo, right, the Apollo 11 astronauts, a lot of people who weren't alive at the time forget, they were put into quarantine for 3 weeks when they came back. Everyone was pretty sure there was nothing alive on the moon, but they were like, but it's not worth the risk. And they quarantined them. I think they even did with 12 as well, before they finally became convinced, after also analyzing the rocks they brought back, that they were like, yeah, there's nothing alive on the moon. It's fine. And they stopped the quarantining process. But that just goes to show they weren't taking any chances. You know, they took it very seriously. Okay, so I have heard this all the time. Why didn't you put something on the rover's solar panels that could clean them off? We got that question a lot. Keep in mind that Curiosity and Perseverance are not solar powered. We realized the limitations of that. And so once we had demonstrated that rover missions were the future of exploring Mars, we shifted with Curiosity from solar power to nuclear power. So they are both run with nuclear powered batteries, which is why the dust storm that killed Opportunity, which was the worst one we'd seen in 40 years, didn't really affect Curiosity at all. In fact, it continued to make observations of the dust storm where it was throughout the whole storm. So these rovers are not bothered by dust, and they are not bothered by that. But we got asked, why didn't we put something on Spirit and Opportunity? And there's a couple reasons. One is that the air is very thin, which means anything like puffing air really wasn't going to do a lot. And also the dust there gets electrostatically charged, which means you blow it up a little and it'll just come right back down on you. It's like the styrofoam peanuts on a cat. You know, it's not going to go anywhere. And anything like a windshield wiper or a brush had the potential to damage the solar panels. It can scrape them and scratch them, decreasing their efficiency. It was also just one more moving part that would be extra money and something more that could break. And the machines are so complicated that something breaking on one part could affect other parts. And a classic example was something that actually did happen on Opportunity. All of the joints on the rovers have heaters, have individual little heaters to heat them up at night when it gets too cold. And there was a heater on the arm joint on Opportunity that after we landed, we discovered was stuck on. It was constantly on whether it was needed or not, and it was draining the batteries. So that was one little piece that went wrong that ended up almost ending the mission because it was zapping all our power. And the only way we could find around it was to shut the whole rover down. Now, of course, you know, you're like, but you want to run the rover. So we would have to do what's called a deep sleep at night, where we would have to shut the whole rover down at night. And every night for a very long time, we came in wondering if this was the night that something in the rover froze over and it wasn't going to wake back up. And that was life on Opportunity until we became confident that it could survive these deep sleeps by just getting nice and warm and toasty during the day and holding on to it. But so yeah, every little thing you put on a rover has risk. And so we looked at everything and just decided, let's just be happy with a few months and let's not add extra complexities and something that could just not even work. As I said, you try and brush it off, it just comes right back on. But like I said, the Dust Devils turned out to really be an amazing thing. InSight, which is a lander that is on Mars right now, though, is run into a problem of people say, well, why not just use solar panels? They worked great. InSight is actually in the situation of there's a lot of dust on its solar panels. It's not a rover, it's a lander, but there's so much dust that they've actually had to go into power saving mode because they just haven't been lucky enough to get a dust devil in a long time. And they don't know if they're going to get one. And they don't know at this point if they're going to wake back up. They are doing some minimal operations. But yeah, it's kind of tense there right now because, you know, sometimes you just get unlucky. I mean, Opportunity got unlucky with that dust storm. So solar panels yeah, to some extent, you're at the mercy of the luck of the Martian atmosphere. And we decided with Curiosity and Perseverance that we didn't want to have that hanging over us. So that's why they went with nuclear power there. Does the rover have, okay, we went over that. Any part programmable from Earth. So any part, yes, can be programmed from Earth. The issue becomes the combination of time delay and only occasional communications between Earth and the rover. So yeah, we could type a command in that would move and do something to one specific part. But of course, that's not the efficient way to run things. We have everything pre-programmed, and you can just tell it, like, do a SuperCam standard observation, and it knows to run all this code and do all this stuff. So it's a very smart rover. But yes, we still possess the capability that we could go in and code something very specific. We upgrade the programming and software on the rovers. That is one thing we can do. We can't change the instruments, right? We can't physically do anything to the rover, but we do upgrade the software that's on board the rover. And so the rovers get smarter as time goes by. It's one of the few things we can actually upgrade during the mission. And so, yeah, when a problem comes up, like Opportunity's heater stuck on, we do have the capability to dig deep and command it to do things that we never thought we would want to do. And it requires digging deep into the code. But yeah, ultimately we have complete control over the rover, though usually we leave it up to the rover to give it very high level instructions, and it's smart enough to do the things on its own.
Are there any other questions out there, folks?
I will say these have been great questions. I've loved these questions.
Yeah, you know, actually, let me take the technical edge off and ask you a trivia question. When will the next remake or re-release of Robinson Crusoe on Mars come out? There's already been one. I remember seeing it when I was a kid, and then they made a recent one with, I don't know, Brad Pitt or something in it. Is there going to be another?
I'm gonna have to look this up. I had not heard of the recent one. Now I'm gonna have to go look that up. So no, I do not know.
Guess what? He finds life underground.
Hey, plausible.
Well, thank you very much, folks. A big round of applause. Let me ask you to turn on your mics and give her a big round of applause for Zoe Ponterio.
Thank you. Yay.
Everyone, that's wonderful to hear. I don't get to hear that enough. I will say thanks for bearing with me on this. I'm actually feeling a little run down, but for a good reason. I got my first COVID vaccine shot on Friday, and it kind of feels like this light at the end of the tunnel of like, oh, it's one step closer to being able to do these things in person again. So I was feeling a little tired today, but this was actually a great thing to kind of like, nice pick me up to spend time with you guys.
Okay. So once again, for the late arrivals, let me urge you to get in touch with the Community Council if you'd like to be on our mailing list. I'll put up a slide in a moment that has that address. We have the Decorate Your Driveway and the Danby tourist, what should we call it, excursion. Put something at the end of your driveway that everybody else can take a look at. And with all of that, once again, thank you very much to Zoe. And let's put on the end. Say again. Was there a question there? Maybe not. So here's the end title. And
I also did, for anybody that joined later, I know they can't see the earlier chat, I just popped the link to the landing footage in there again. So yeah, before you leave, click on that and go watch it.
Also, I grabbed all those URLs and I'll add them to the description of the event on the Community Council webpage. There's the URL for it. What you'll end up doing is looking for the past events page, and those URLs will be on there. And if you want to get on our mailing list to hear about future programs, not all of them are about life on Mars. Some of them are music, some of them are informative. Some of them just take up your afternoon if you have nothing to do. At any rate, there's a URL and an email address. And thank you very much for coming. See you again another day. Thank you, Zoe.
Thank you very much.
Thank you.